Cool. Hi everyone. Um, Notice my webcam sometimes needs a moment. So, um, lots of stuff. I might not run all of this code. Now, just to be clear, all of this code is actually runnable. I've actually opened up the lectures repo here. You can find the lectures repo by going to this link here and cloning this link, and I'm literally going through all the lectures in lecture-1 today. You can go and find all of these. These are all the things we're going through. Um, but, yes, they're all in the slide. So, firstly, basic types. What types are there in C++? Well, you're probably familiar with types from a language like C, like int and double and char. You know that there's not types, like there's no bools, for instance, in C. You use like ints for that. But in C++, these are kind of some of the basic types we're dealing with. So firstly, we have ints, we have doubles, just like you'd expect. This right here is basically just writing some testing code. So like you don't need to worry about this. Like this is if you were writing a test. We also have strings. So in C++, there's actually a notion of a string. So C++ strings are, in terms of usage, a lot closer to what you might be familiar with Java, for instance, rather than like C. So it still is obviously going to be an array of characters under the hood, just like I think that's true for pretty much all languages. But you deal with it a little bit more like a Java string, right? So this probably looks like a Java string. We have like the string type in C++ is std : string. We'll keep talking about what that std means. And then you just make a new object. So one thing that's also important to understand about C++ types is that it is also a little bit like Java in the sense that you do have a handful of primitive types like int and double and bool and stuff like you see here in char, but all the other types are essentially objects, and you're familiar with objects because of, a course like 2511 or the prereq. And that means that when I say standard string here, I'm actually instantiating a new object of some kind of class type that's written in a library, right? So same as kind of Java stuff. And that's also why you see here that for our type like course code, I can do things like call .front on it, because it's just like Python, it's just like Java. A string is an object. Whereas in C, when we deal with strings, they're actually just char arrays. They're not an object, they're just an array. It's a primitive type, but here they're actual objects. So this code here is written inside of lecture 1 types. So this one's actually written as a test case. So a lot of the first week of lectures, we've opted to write the sample code, like the lecture code, as tests to kind of just get you familiar with like what writing test looks like, because it's going to be in the first assignment, So, to run something like this, for instance, you would just say, build target demo 100. You'd run it. It would compile. It's still compiling here. See there? It's like still compiling. I'd have to wait for that to be done. Sometimes first compilations can take a while because it's probably because it's like having to compile it with Catch 2, the testing framework. I think I kind of skipped over this in the last lecture too, but you can kind of look up the Catch 2 framework on the internet if you want to get like more familiar with the syntax. But generally speaking, like the samples that we have in the lectures will be like a good place to start, and only once you start writing a lot of code will you want to actually go and like try and have a look at the references. Yeah, I think there's like this is the whole doc that most of this you won't need. So I'm just letting you know now. Generally speaking, you can just follow the patterns we've got. Sorry, I was compiling and running code, right? So build /test/test 100. What is it? Demo 100, sorry. Ugh. What's wrong? What am I doing? Oh, I need to... No, I'm confused. Build /lectures/lecture1/demo 100. So notice this here as well, is that in the previous tute, we had all of our files inside of the test folder, whereas here we have our files inside of lectures/lecture1. So when I want to run that binary directly, I have to go build /lectures/lecture1 1, and then the name of the file, and then it says all test pass. Firesyn says, so is Catch 2 actually stored locally like other lib files, or does CMake like download it? Well, CMake downloads it and then compiles it. Like if it doesn't have it, CMake will download it, I believe. Could be wrong. I don't know, but I'm pretty sure it does. I'm sorry that I'm not 100% certain. I just haven't bothered to ever ask that question either. So there's some basic types, really simple. Now we'll be able to breeze through some of these other bits more. One thing I did want to point out, which I think is an interesting little nit of C++ is, again, it's a hardware-specific language, right? And what that means is that unlike Java, as we've talked about, things like ints will be different sizes. So for instance, if I Google int size C++, and we go to Google here, I don't know what specific link I'm looking for, but there's this is why you don't do impromptu stuff during lectures. But you can Google this stuff and you'll find that basically on some machines, I think it's a long, I think it's like C++ integer types. Numeric types, sorry. So on 64-bit machines, I'm pretty sure that there's a different size for an int than on other machine, like a 32-bit machine where it's 4 bytes, and I think it's a long. So I think ints are always 4 bytes, but longs can be 8 bytes on 64-bit machines, and it can be 4 bytes on a 32-bit machine or something like that. So it's just important to understand that, because unlike a different language that is wrapped in a VM, C++ will actually have specific limits. So there's these little pieces of code you can run, which I know don't make a lot of sense to you right now. But if I was to run this one here, demo 101, this will actually print out what the maximum and minimum size of an int and a double is on your machine. So I could actually, here for instance, run, I have to get rid of this, demo 101, and it'll actually show you the maximum int you can get is that, and the minimum int you can get is that, and the maximum double you can get is 1.797 to the power, times 10 to the power of 308, and that's the minimum, right? That will vary on different machines, and that's why languages like this are both faster and harder to program in sometimes in something like Java. Now, Kai's asked a question here, which is, what's the difference between dot and colon? Now that's a great question, because I know some of you are familiar with languages like Python or like Java, which will use dots. Generally speaking, the double colon is not so much like a dot, because the behavior of dots is pretty similar in C++, right? A dot is how you have an object and you invoke a property or a method of that object. So something like this here, course code dot front, makes sense, right? It's just okay, the course code is a string object and then it has a dot front method. Now, again, in Java, if you were to do something I again haven't written Java in 5 years, but I think it's if you were string equals new string hello, I think that's Java, right? You're creating a string object, and there's the Java doc which shows you that. In C++, and I'll just show you this here while we're keeping to the really basic example. Oops, that's the wrong thing. So just by the way, every time you Google something with C++, you're going to get 2 links. You're going to get this c++.com link, and you're going to get this cppreference.com link. Generally speaking, the course staff don't like this website, don't think it's very good. So always look for the CPP reference site. You're probably going to get the same information on both, so don't stress out too much, but we have our preferences. And it's going to be a whole lot of garbage here and stuff that doesn't even fully make sense to me. I don't even know what the hell this is trying to explain. I could probably figure it out if I thought about it. It's all a bit confusing, and we're going to keep coming back to this the entire course, but you'll see things here that are very Java doc-like. For instance, member functions. There's the front function. So for a string, you can get the front of a string. You can get the back of a string. You can get the... you can get a pointer to the first character of a string. You can get the size of the string. There's tons of stuff you can do. It's like an object. I can get the front, and when I click on that, it'll tell me, you know, this is how you invoke it. It returns you a char t, whatever that is. It's a character. I'm not really sure the subtleties of that. Yeah, it gives you some behavior of it. So it's a pretty good library compared to some other languages. Now, the double colon is essentially a scoping mechanism. And what that means is that, and again, you might be familiar with this from Java. Like if you have Java and you have a string, and you have a static member of a string, you know, like maybe string dot like max length or something, right? Max length is essentially a property that's part of the string class in Java, which makes it a variable in the scope of a string scope, the class scope of a string, right? In C++, we use double colon a lot to say scope. Essentially what we're saying here then is that we have a name called string, but it exists inside of the std scope. We're going to be talking more about this next week, but basically all of the standard main C++ things you use will be inside of std. So a lot of like the core functions and data structures, you will write std : and then the name of it. That'll make more sense as time goes on. In the meantime, just write it. Yeah, most objects you work with will have that std. Okay, moving on. Next part, auto. So we talked about some basic types. I'm sure that you could write some really simple things in C++. Like, you know, sum two numbers or print out a string or do something like this, get a string, get the first character, check if it's the same, right? We're getting the first character of this string. But to get into some new features of C++, one of the most important and relevant ones is the use of auto. Now, as you know, C++ is a statically typed language. I mean, maybe you didn't know that, but like it's like C, right? C is statically typed. It has strict typing. You need to the compiler needs to know the type of all like variables and things being operated on at compile time. That's sometimes annoying to write things out. Now, again, you might be thinking, that isn't too annoying. I don't mind writing int, but again, if you think back to Java, just because it's an easy example, it's all fine in Java until you're like, you know, I have an array list of a string called cat, which is equal to a new array list of string, like, right, until you start doing something like this. And it becomes quite cumbersome then, because you're like, the left-hand side should be totally determined by the right-hand side. Like, if you know the right-hand side is this object, then when you're assigning this object to the left-hand side, you should know it's a goddamn array list of array lists. Like, we know that. So I don't need to tell you that. I just want to say, like, you know, figure it out. And that's essentially what auto is in C++. It allows the compiler to make a decision on the type of the left-hand side variable based on the value of the right-hand side. And it always happens during declaration. So if you remember from C, right, if you do this, this is what we would typically call declaration, and then we would call this initialization. The rules surrounding auto are quite simple. Auto can only happen at declaration, right? Because once you declare a type of a variable, it stays that way. I can't now say auto I equals 5.5 or something, because it's already been declared, right? It's a redeclaration error. The other thing about auto is that when you replace this with auto, you can no longer declare without an initialization, or what we call a definition, immediately after that. So I can't just say auto I the same way I can say int I, because with int I knows it's an int. With auto I, it's wanting to make sense of it based on what's on the right-hand side, but there is no right-hand side, so it freaks out. It's like, oh, I don't know. So you'll see some examples here. We have auto I equals 0, because 0 is an int, it will set I as an int. J equals 8.5. 8.5 is going to be a double. I think it's a double. I mean, I guess it might be a float. I think C++ might just default to double because it has a higher precision than float. You can also see here that if I create a standard vector of ints, which is something we're going to chat about later, but this is basically an array. Like if you just think about it, like this is really the equivalent of array list. But we'll be talking about that in later examples. If we create like a list or an array of integers called f, and then I say auto k equals f, it like k will be a vector of ints. It'll be a list of ints, right? Because it uses the right hand side to deduce the left hand side. So that's kind of the gist of auto. Ifan has said, do we get performance penalty if we use a lot of auto? No, you don't. Auto is considered good practice. We actually give you, we'll give you a, oh, sorry, performance penalty. Gotcha. Well, let me first say, auto is an expected convention of how we want you to code. So if you don't use auto when you could have used it, you'll get in trouble. Because it makes code cleaner, it makes you less likely to make mistakes, just it's generally well accepted. It doesn't totally eradicate the need to use types anywhere. Of course, like everything is still typed. Auto is just helping you say to the compiler, I've already given you enough information. I don't need to write this out for you again. Arthur says, does auto work if the variable is assigned to something that can't be determined at compile time, e.g. user input? Well, sort of, but like user input is always going to be a type, right? Like if you're reading in user input, it's going to come in the form of a string or a char. So the way you receive user input is still known at compile time, even though the input itself is not known. But yeah, Irfan says, do we get a performance penalty if we use a lot of auto? So it's important to remember that auto is used at compile time, right? Not at runtime. So it's not going to make your program run slower at all, because all it's doing is like asking the compiler to think a little harder at compile time. It probably, I don't know, it probably makes your compile time finitely slower, irrelevantly slower. Like I'm sure if you benchmarked it, it would be like a touch slower. I don't know, maybe not even, but no, it doesn't make your actual code run any slower because again, it is compile time. While we're here on this example, I'm also going to take the opportunity just to show you a vector and how C++ has objects as well. So we know that we have an I and a j here, right? Pretty simple. I could like print them out. Standard C out, we print out things like this. The other thing you'll notice about printing with C++ is that like I can join like strings and not strings like this if I want to, and it will just like print them out. It actually behaves a little bit like concatenation, if you're familiar with like concatenating strings when you print them out. So I could actually do things like, or maybe I can't. Let's try it out. I honestly program in too many different languages these days and my brain melts. So I'm going to compile this code and I've just got auto I equals 0, auto j equals 8.5, and then when I go to my terminal here and I run build lectures lecture1/demo 102, it prints 0 and 8.5, right? So it prints them out. What happens, actually, do you notice here how I can kind of like concatenate strings and non-strings like that? Very powerful way of printing in C++. But what we're essentially saying here is like, if you imagine this is just where we're printing, it's like print that, and then print that, and then print that, and then print that. But if I want to add those together, what's it going to print, right? Well, you know this from C languages. I and j, when you add them together, they'll both turn into doubles because j has the higher precision, and it will turn it into 8.5 because we just added 0 to 8.5. There's questions in the chat, but I think we're going to answer them all. So, great. You can't do auto k because again there's no right hand side. We've established that. The next thing we're going to do is we're going to make a new vector, a new variable called f, which is a standard vector of ints. Now again, the std is just what we put in front of most of our data structures and algorithms. We won't get into that too much. But a vector, which is a funny name, is basically an array. It's basically a dynamically sized array, and we talk a lot more about this next week. But again, you need to lean on your Java knowledge here to make sense of this. It's an array list of ints. It could be an array list of doubles, it could be an array list of chars, but in this case it's an array list of ints. And I can do things with that, just like I would otherwise, right? This is an empty array at this point. But if I want to push something to it, I can use push back. Now, how do I know that I can push something to it? Well, I can go to, oh wait, standard vector C++. I'll go to the library right here, standard vector. And I'll go down and I'll see there's a whole bunch of functions on it. Like I can push back, adds an element to the end. So I can add an element to the end of the array. Great. Now I also might want to print out the size of the array. So I can do f.size like this. So this program will create a vector of ints called f. It will push 5 to the back of it, and then it will print out the size of that array. And I might print out the size of the array before I push to it as well. So what I'm trying to demonstrate to you here is that C++ really does effectively, I knew this would happen. C++ really, Control C, Shift C, I can't remember. I can't remember how to do the new line. It effectively feels a lot like an OO language where everything's objects. So if I run this now, terminal print, 0 and 1, great. Okay, so the 0, I add an element, there's 1. You get that. Now the next line is interesting. Auto k equals f. Now someone has asked in the chat about this, and Luke's already answered it for us, which is helpful, which is when I do this, when I say auto k equals f, the compiler will know that what I'm actually saying here is that k equals f. It knows that it's that type because it can tell from f. But the question is it a copy or is it a reference? Now, if you are working with Java, which treats all object assignments like reference sharing, it would be a reference. But the way C++ works is the other way around. In Java, whenever you say object A equals object B, both of those variables are kind of now references to a heap item, right? Something on the heap. But with C++, it's actually a copy. And to make it a reference, you actually have to do an extra step. So it's copy by default. That's what we call value semantics or copy semantics. But this is now a copy. So we actually have two arrays. And you can see this here. If I now push something to k, and then I try and print out the size of k and the size of j as well, right? So I'll just try and print out, sorry, the size of f, right? So I push something to f, I copied f to k, so they both have one element, copies, and then I push another one to k, so therefore it should not be adjusted. So let's try that. So build 102, perfect, terminal. Yeah, 1, 2, 2, 1. So 2 is the size of k, 1 is the size of f. So we've just demonstrated that doing a standard assignment actually does a copy. And we'll come back to that a lot more later as well. Why is there no return 0 at the end of the main function? That actually happens anyway. Like if you don't actually write return 0, C will just return, C++ will just return 0 for you. I think it's the same in C. I think it's just generally taught as good convention for younger students. What if we do like a shallow copy? Would there be a way to get that behavior if we need it? I don't want to go into this too much in this basics lecture, but the short answer is that it doesn't do a shallow copy. And we'll deal with those cases more in assignment 2. Faizin says, so does a large vector require some time to be assigned? Yes, it does. If you have like a million items in a vector and you say auto k equals f, it's going to copy a million items, right? It'll happen. So, you know, got to think about what you're doing. Great, there's auto. We really talked about that for a little while, but it's interesting. The next thing is const. So these are all compile time things. Const is a keyword that exists in C++ that after declaration, it says it can't be modified. Right? Now, we're kind of familiar with this concept, I think, from Java. I don't think it exists in many other languages. But essentially, we use the word const and can't touch it anymore. So, for instance, if we say autoconst meaning of life equals 42. Now let me just pull up this code example. Oopsie. Just pull up this code example here, const. Autoconst is the equivalent of saying int const, right? Because auto will determine it that it's an int. This means that after this point of declaration, it can't be changed. So if I was to try and and I'll show you this, right? If I This is a simple program. Let's actually run it first, right? We declare two constants, meaning of life in 6 feet in meters, 42 and 1.8288. I go to compile it, build 103. It should build quickly. Notice the catch 2 ones sometimes take a bit longer. We'll just do 103. I know my face is in the way, but you know what I'm writing. All tests pass, right? So it passes it. But now watch what happens if I go meaning of life plus plus, right? I try and mutate it. I try and modify it after it's declared as const. It is picked up at compile time. The compiler says absolutely not. C++ compile errors are not really the most friendly sometimes, but usually they're a lot better than C. And you see right here, line 17, column 24, cannot assign to variable meaning of life with const qualified type const int. Basically, it's like this variable, you have told me that it's const, so I cannot assign to it. Like it cannot touch it. So it's a couple things. Now, why do we like const? A bunch of reasons. One is it makes it clear to developers that it shouldn't be touched. Two is in some cases, this is not so much true anymore, but compilers might optimize for it. If a compiler knows something isn't going to get modified, it might do things more efficiently. And the third reason is that it helps you pick up on mistakes while you're programming, right? If you try and modify something that's const, it won't even let you compile. So lots of benefits to it. In general, two principles that we follow in this course. Everything should be const by default, and you should have a reason for it not to be const, i.e. that you would like to change it. And secondly, whenever you write const, it always sits on the right-hand side of the type. So it always sits on the right-hand side of the auto, it sits on the right-hand side of the int, because you can actually validly compile it like this, and that's probably actually where you'll see a lot of examples online. Sorry, let me just get rid of the the line that's preventing it from compiling. This will work, right? But just for convention, we like it on the right. I can't remember off the top of my head why that is. That was the thing that came from Christabella. I'm not sure if there's a lot of depth to it, or if it's just one of those things that like the echelons of the community just decided, let's do it. Yeah, I'm not sure. I'll dig into that one, but that's the convention we're going to ask you to follow in the course for consistency. So const, pretty simple. Don't think there's a ton of questions about that. Oh, more code. I just kind of answered this stuff. Oh, this last point's interesting. I forgot about that. So, you know, C++ might be used in situations where you're dealing with multiple threads, like multi-threaded programs. We don't do any of that in this course. It's just like kind of beyond the cusp of what we're doing. But if you think about, like, if you've done a course like OS or dealt with any kind of concurrency, concurrency is only a problem when you're dealing with shared mutable memory, right? Like when you have 3 different threads randomly operating on some shared data that might change. So if you know it doesn't change, then it makes things a lot easier to deal with in a multi-threaded sense. Okay, probably got time for a couple more slides. Expressions. So, an expression in a programming language sense is a combination of values and functions that are interpreted by the compiler to produce a new value. Basically, like a lot of the time, an expression is the right-hand side of an assignment, right? Like when you say auto I equals 4 plus 3, it's the 4 plus 3 that's the expression. It's a collection of values and functions that are interpreted to produce a new value. And we're going to explore some basic expressions in C++. Diarmoid, I'm not sure how to pronounce your name, sorry, said, are there downsides to using const? Not really. I mean, the only downside is that you can't change the variable that you made const, but you wouldn't make it const if you need to change it, right? So it's kind of a very easy thing to apply. That's what I mean. It's like everything's const unless you need to change it, then it's not const. Oh, sorry, yes, Clarissa, I didn't see that question. Yeah, in the previous slides we say east const. East is to the right generally, like if just wherever your right hand is generally where east is on a map kind of thing. So we call it EastConst because it's on the right-hand side. I believe that's the term that's kind of the lingo in the community. But we're going to look at some basic C++ expressions. What you notice here is that it's all pretty similar to C, right? You've got plus, minus, times, divide, mod, and yeah, like it's all pretty straightforward. There's a whole bunch of like really useful parts of the C++ library as well, and like I think like we just try and trickle these towards you. But you notice here in this expression sample, in the floating point arithmetic, right? This one's all about like all the integers, which is very similar. In the floating point arithmetic, which is exactly what you'd expect, on line 48 here, we're actually doing a delta check, which like, I hope I don't have to explain it. I hope CSE teaches you this somewhere else, but you know, floating point errors, right? The idea that when you sum two floating point numbers that aren't in approximately the same magnitude, you get errors and a loss of precision. Which means that when you actually, like, with languages like C++, when you check if two floating point numbers are the same, like doubles and floats, you actually can't check if they're totally equal. If they're sometimes you can't check if they're totally equal. It's not always safe. So instead, you check if the difference between them, you basically subtract one from the other, and it's going to give you a number that's really close to zero, like super tiny, which we call a delta. So when we compare those two, instead of checking if they're equal, we actually sometimes will subtract the two ones we're comparing and check if its size is like near zero. But to do that, we need to get the absolute number of something. So in C++ here, you can see that we're using standard abs, which it's in CMath. So to use, yeah, epsilon, sorry, it's an epsilon, right? Delta or epsilon, same thing. I think it is. I'm not a math major, but pretty sure it's epsilon as well. But you'll see here we're actually using standard abs. So like in C, you might use like pow or some other function that does some math. But here we're using standard abs, which is absolute value. But to use that function, we've had to import this library, which is CMath. And if I don't import that library and I tried to build this, we get an error. Or we don't. What's CMath being used for then? Abs might be built into the actual compiler. I'm not sure off the top of my head. But just to be clear, this is a massive language. Like I tell people all the time that like getting your head around C++ nearly requires more brain space than like getting your head around C, Java, and Python all at the same time. So like, I will make no apologies for the fact that there are a lot of things that I both don't know and that I don't keep at the top of my head. For instance, what abs is used for. So you can see here that when you go to the reference, it actually says that standard absolute value is actually defined in C standard lib or CMath. A lot of the time, there's C++ equivalents for these libraries where instead of like including like hash include stdio.h, you actually include c.stdio, which is like the C++ equivalent of the C library. I think it's the same library. So CMath is basically saying math.h from C. The thing is though, when I don't include it, it still compiles. Why is that? Now, it could be because I've made a mistake, which is certainly possible. But more likely, you actually see this happen sometimes because the string library itself, or catch2, will actually include CMath as part of its library, right? So therefore, when we go to compile it, because remember, hash includes copy and paste like entire headers into your file, and if that header includes CMath, then you don't need to actually include it. We do want you to include it though, because it's good practice. So one of the other rules about C++ design that we are enforcing is that we expect you to always include the libraries that you use, even if it's not required for compilation. You like if you're using a function that's from the CMath library, you include CMath in your code because it makes your code less fragile, right? Because if you just rely on other libraries to import it for you, then it's not going to work. It's not multiple libraries that, I don't know why there's multiple libraries that define the same thing. I have no idea, to be honest. That's actually a C question. You could actually ask someone who knows C as well, like why does standard lib.h and math.h include abs? Surur says, can we call the main function inside our test file? No. Your main function is a replacement of your test file is a replacement of your main function. So typically you'll write code that does stuff, and then you'll either call it from your main function or you'll call it from your test file. That's kind of the main ways you'll do it. But coming up towards the end of the lecture here, and I'm just going to bash through the last couple of things because they're pretty intuitive. String expressions, we already kind of talked about strings. So, you know, you create strings, they're objects. This line is actually something I wanted to remove but forgot. I'm sorry, so you can ignore that line there. And we talked about them being copies of each other as well, right? And that's why, like, if you compare if they're the same, you actually get that true. Because, like, we're going to talk more about that in week 3. But yeah, essentially you can copy strings and they're going to be the same. And then lastly, you have Boolean values, which are exactly what you'd expect. One of the only, I guess, subtle things here is that as part of C++20, you can actually use like Python and or and not, as opposed to like the standard double ampersand, double pipe, or like exclamation mark. Both of those are applicable, though in general we encourage you in this course to use and or not, because it's more readable, right? Auto is more readable than 2 dashes or whatever symbol they might want to use. So generally speaking, try and use and or and not in your code instead. So that's demo 104. When we do this video will be in 2 parts. When we continue this tomorrow night, we will keep going from value semantics. Just the last couple of questions here. Bob says, so each test case will be a main function. Essentially, like each test file acts like a main function that will run. It's a simple explanation. Quinjian says, how about import function into test file? Yeah, you can import functions into test file. It's really no different to like a C file that you have a main function with a bunch of asserts in. It's the same thing. It's just a structured library as opposed to asserts. And Kai says, when we call a class constructor like standard string, we don't need new like Java. Yeah, so that's correct. With C++, it's just kind of obvious. Like, it's like, what else are you doing? Like, you don't need to say new because there's like nothing else you would be doing there, you know? Because standard string with that is basically a constructor call, which will return a new object. So yeah, you don't need new. That's just a different syntax for the language. Anyway, it's 7:57, so made a bit of progress into that. We might actually finish this lecture tomorrow. I don't want to say that. I'll probably regret it. But yeah, so I'll see you all tomorrow night. It's good to see so many people here. We have a third of the course here tonight, which is pretty good for COVID days. It's really nice to see everyone. It's been a while since I've taught, like a month. First lecture of the term, maybe for some of you as well. So I hope you have a great night. Some of you will start tutes tomorrow, including my tute. I actually think my tute's the most boring tute because I'm most likely to tell you the same thing that you've been told in the lectures. So if you're enrolled in my tute, I'd actually nearly encourage you to go to someone else's tute to get a different perspective, but I will still record my tutes for those who miss the tutes. I'm dead serious about going to someone else's tute because I will just like tell you the same things I know. We'll talk about OO a little bit. But anyway, I'll see you all tomorrow night, and thanks for coming along to first lecture. See you, everyone.